This is the first game of the logic game section of the Juno 7 exam, which LSAT offers for free as a sample test. Here are the scenario and the rules for the game. If you'd like to try playing the entire game on your own first before we talk about it together, and if you're watching this on YouTube, please check out the video description for a link to the full game. Otherwise, if you just want to play along with the video, go ahead and pause this screen if you'd like to try setting up this game on your own first before we walk through it together. Okay, so let's talk about how to set this up. For this game, we've got 5 numbers, 0, 1, 2, 3, and 4, that we must place in some sort of order, with each element appearing exactly once in that order. So we can start by writing out the elements to be placed on the side, and we can visually represent the situation with 5 slots to represent the order of the numbers as they appear in the code. The third rule tells us that the second digit must be twice the first. There are only 2 ways that we can satisfy this rule. The first digit can be 1 and the second digit 2, or the first digit 2 and the second digit 4. We can split our diagram into 2, a strategy called framing, in order to represent these 2 possibilities. Notice that once those elements are placed into those first 2 positions, the game itself becomes very limited. For each frame, we now only have to consider 3 elements for 3 positions. The final rule tells us that the third digit has to be less than the 5th. In either frame, there are very limited ways in which this can be true. We can split up our frames further to represent these limited possibilities. In the first frame, the 3 numbers we have to work with are 0, 3, and 4. And there are just 3 ways in which these 3 numbers can satisfy this last rule. The third digit can be 0 and the 5th digit 4, or the third digit can be 0 and the 5th digit 3, or we can have 3 as the third digit and 4 as the 5th. Placing these elements also allows us to figure out, for each situation, which remaining number fits in as the 4th digit. For the second frame, the 3 numbers we have to work with are 0, 1, and 3. And there are just 3 ways in which these numbers can satisfy this last rule. The third digit 0 and the 5th digit 3, the third digit 0 and the 5th digit 1, or the third digit 1 and the 5th digit 3. Again, in all these cases, placing elements in the 3rd and 5th positions also allows us to figure out which number must go in the 4th position. Now we've got our game split up into 6 total frames, and though that did take a bit of work, the value of it is that these 6 frames completely represent all of the given rules and every possible ordering of digits that can satisfy those rules. These frames are going to make it markedly easier to solve all the problems to come. Also note that I'm going to go ahead and number the frames for the sake of our discussion, but you certainly don't have to do this when you're playing games on your own. Here's the first problem. Please pause the video if you'd like to try it on your own first before hearing the explanation. If the last digit is 1, we know we're dealing with the 5th frame. Looking at that frame in the answer choices, A is the only answer that has to be true. And so, A is correct. Here's number 2. Again, go ahead and pause the video if you'd like to try it on your own first. We are looking for an answer that must, in all instances, be true. Looking at A doesn't have to be true in many of the frames that we have. Looking at B doesn't have to be true in frame 5. Looking at C has to be true in every single one of our frames. So, looks like it's going to be correct. Looking at D doesn't have to be true in many of our frames. And looking at E also doesn't have to be true in many of our frames. So, going back to C, it is the correct answer. Thinking about it a bit more, 2 must always be one of the first 2 digits in the code, and the number 3 never can be. So it makes sense that 2 must always be before 3. Here's the third problem. For this question, we're told that the third digit is not 0, and so we know that we're dealing with frames 3 and 6. In these frames, A, B, D, and E don't have to be true, but C has to be true in both frames, and so C is the correct answer. Here's question 4. We are looking for a pairing that isn't possible. We can look down our list of frames and assess the third and the fourth positions. Answer choice A is possible in frame 4, B is possible in frames 1 and 5, C is possible in frame 6, D is possible in frame 3. But E is not possible in any of the frames, and so therefore E is the correct answer. Here's question number 5. We're looking for an answer here that is consistent with all of the frames and thus always must be true. Starting with A doesn't have to be true in many of our frames, so we can go ahead and eliminate it. B doesn't have to be true in many of our frames, and so we can go ahead and eliminate B as well. C doesn't have to be true in frame 2, so we can cut C. D doesn't have to be true in frames 4 and 6, so we can eliminate D as well. And then finally, E is true in all frames, and so E is our correct answer. All right, that's it. Hope you guys found that helpful, and if you did, please check out the other free games and problems I have posted on YouTube, and also check out the LSAT Trainer website. Thanks so much for watching. My name is Mike Kim. Take care.